to name it. So let's name ions, ionic and molecular compounds, and let's start with the ionics. So starting from the ions. So non-metals form negative ions, right? The name will drop, and we add IDE plus ion. For example, chlorine. So we're gonna drop I and E, and we're gonna replace with IDE, will be chloride. So if you go to bromine, so we're gonna drop I and E, and it's gonna be bromine ion. Yes, you need to write down ion. Chlorine will be chloride. Fluorine will be fluoride. Iodine will be iodide ion. So what is that? Nitrogen, so it will be nitride ion. Oxide ion, phosphide ion, and sulfide ion. So pretty easy. The only thing that you did was drop the end of the name and replace with IDE plus ion. How are we gonna do? Give it the symbol. For example, when you have the Roman numbers, means we have a different charge for that element, so they can vary, and you need to represent that with the Roman number. So like here. So here we have sulfide ion. How you represent that? First, you represent the name, and you're gonna use now the symbol and the number of the charge. So the number of the charge is -2 because sulfate is in the group 16. So it's -2. Lead is already giving me what is lead is 4. So this is what I need to write down. So since I introduced here for you the Roman algorithm over here, let's go to the simple ions, cations. So when you have a metal, we form positive ions, right? Cations. So metals that form only one type of ion. So we have calcium, like 2, so we calcium ion. So it will be exactly the name of the metal. So that will be magnesium ion. This will be lithium ion. But sometimes metals don't have fixed charge, mainly the transitional metals over here. So when they don't have fixed charge, you need to indicate that using the name plus Roman number and between parentheses plus the ion. This we call Stokes system. So that is the charge of the element. Like here, we have iron 3 ion, cobalt 2 ion. Okay? Now mercury 1 ion is diatomic, so we have this charge. So polyatomic ions. You saw a compound a few slides ago that I used nitrate. So that was a polyatomic ion. Remember that it was a metal and the polyatomic ion that it was like this is ionic compound. So polyatomic ions is when you have 2 atoms together and the charge is for the whole ion. It's not only for the one element in there. So here, so they consist of 2 or more atoms that chemically bond together with a net electrical charge. So table 2.5 that you have on Canvas, there are some polyatomic ions over there like commons. You need to memorize 9 of those. So table 3 on the sheet, title, important tables, look at that. So you're gonna name with the name plus ion and the formula, symbol, charge, superscript. Like here we have perchlorate, and you need to look at the periodic table like here. The one that I was talking, that my video was covering, it was this, perchlorate ion. So here I have a hypochlorite ion, chlorate ion, chlorite ion. See, I have a sulfate ion. You need to pay attention to the charges over here. This charge is the whole polyatomic ion. So I have a hydrogen sulfate ion, hydrogen carbonate ion, so all those ions, okay? So let's name binary ionic compounds. So we know that ionic compounds are metal plus non-metal. And how are you going to write down the name? So the first thing that you need to know is, or to remember, is which compound I know, an ionic compound, that will bring to my head the rules of the nomenclature without memorize. The one thing that you use at home every day, salt, sodium chloride. Pay attention on the name, sodium chloride, sodium chloride. See how we roll sodium and then the ion. The non-metal received the name of the ion, chloride. And you learn how to do this. Drop the last letter as INE and replace with the IDE. So if you have metals that has a different charge, of course, we gonna do what? Yes, we gonna represent that, show that charge using Roman numbers. So let's go. So write the name of the metal. If the metal doesn't have fixed charge, write the charge as Roman number. Write the name of the metal, replace ending with IDE. So what is that? FeCl2. What is that? So iron chloride, right? This will be, look at this. This is the charge of the iron. So this is iron 2 chloride. This is potassium oxide. What is the name of this? Manganese. Look at the charge over here. That's a transitional metal. So the charge is over here, 4. Manganese 4 iodide. What is this? Titanium phosphide. Okay? So how I know? Because phosphide has -3 as in the group 15, so it's a -3 charge. So if I don't see numbers over here, is because titanium is +3. So when you cross, I have TIP, so 3 and 3, and we use unit formulas or empirical formula for those. We divide by 3, so that's this, titanium 3 phosphide. Okay, let's go to this. So when you have how you're gonna write down the formula, so I need to cross over the number of the charge. For example, here we have a copper 2, so I have the charge of the copper, and I have phosphide, so I know the charge of phosphide, right? So you cross over, and then we write it then as a subscript. Don't include plus or minus, okay? Reduce to simplest form, empirical formula. So how are you going to do vanadium selenide? So I know selenium, look at this, vanadium, right? It's 4. So it's +4, okay? And I have selenium, which is group 16, so it's -2. So when you cross the charge, we're gonna have this 2 and 4. Oh, selenium 4. Let me just erase that. So I'm gonna use empirical formula. So I divide by 2 both of those, and it will be VSE2. And how are we going to do potassium sulfide? The same thing. I know sulfide is -2, that's sulfur, and potassium is +1. So when you cross the charge, it's going to be K2S. Good? So, unlike this one, so copper 2 phosphide, I know that copper will be 2. What is phosphide? will be -3. So when you cross the charge, I have 3 and 2. Because if you multiply, look at this. 2 times -3 is -6. 3 times 2 +2 is 6. 6 minus 6, 0 is a neutral compound. Good? So, and we have a ternary compound. It's when we have metal plus a polyatomic ion and a monatomic ion. So 3 different atoms, right? So writing names, so you can identify the polyatomic group and the monatomic ion and write the name of each one in order of appearance. If a monatomic cation and the metal has variable charge, write charge as Brahman number. If a monatomic anion, change ending to IDE. So you're going to write each ion with this charge. Place the cation on the left and cross over the number and write then the subscript, as I said. So perchlorate, like we have this -1, and we have sodium, +1. So when you cross this, we're going to have sodium ClO4. Okay? So this is the way you write a formula. It's easy, not hard, but how will you give the names? Okay, so if you don't have the periodic table with you and your hand, you should have your periodic table, and you should print out the tables that I ask you to print. Okay, so we're gonna find on canvas. So here we have a carbonate and we have a calcium. So it will be calcium carbonate. See, the metal is always the beginning. So start with the metals and then you go to the metals or polyatomic ions. We have iron. Iron is transitional metals and they have a charge of 2. So iron 2 phosphate. That is the name of the polyatomic ion. Let's go here, right? The formula. So copper 1, I know the charge of the copper, which is +1, right? And I know sulfate, which is -2. So I have a copper 1 and I have a sulfate with -2. So when you cross the charge, we have a copper 2 sulfate. Aluminum hydroxide. Hydroxide is -1. So, and then we have aluminum with +3. So we cross the charge, and I need to use parentheses to add the 3 over here. Otherwise, if I write down like this, I'm telling you that I have 1 aluminum, 1 oxygen, and 3 hydrogen. And this is wrong. What I have 3 is hydroxyl, okay? So let's name all those here. Let's test your understanding. I will ask you to stop the video and try by yourself. So potassium chloride, potassium oxide, calcium oxide, magnesium chloride, sodium hydride, zinc sulfide, rubidium bromide, aluminum oxide. Here is to write the formula. So we have the name and you're going to write the formula. The only thing that you need to take care of is the charge. So lithium sulfide, calcium carbide, sodium hydride, and magnesium nitride. Okay? If you need to practice more, let's go. Let's keep going. So here I have a polyatomic ions. So again, just press stop in your video and try by yourself. Okay, so we have iron. So just form using the polyatomic ions. So it's easy here. So we have the charge, right? Copper 2. So I know that is the charge of the copper hydroxide. And here, calcium is in the group 2, so I don't need to identify the charge in the Raman number. So it's calcium chlorate. And here I have sodium phosphate. I have iron. Look here, what is the charge of the iron? 2, because it's 2 over here, right? So iron 2 chloride. And then we have iron 2 again. Don't get confused with the 3 over here. This is the charge of the phosphate over here, and this is the charge of the iron. So it'll be iron 2 phosphate. And then we have a lithium chromate. Okay, it's not hard, but you need to understand and bring in your memory some polyatomic ions. To write down the formula is also easy. So we have a potassium group 1, which is positive 1. Nitrate is a polyatomic ion with a negative charge. So when you cross, you simply have potassium nitrate. So magnesium hydroxide, magnesium is in the group 2, so it's +2. And the hydroxide is a polyatomic ion with negative 1 charge. So when you cross, we have magnesium hydroxide here. So you need parentheses. Don't forget the parentheses, okay? And you're going to do this for all the elements, okay? So let's name molecular compounds, finally. So naming is the skill that is one of the most important skills that you're going to have here, okay? Molecular compounds, when they have different elements, you really need to indicate the quantity of each atom that you have. So we're going to use the prefix, like Greek prefix, like mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. And you really need to know those in your head. Which one is which? Like what is 7, septa? What is tetra, 4? Because that will help you to identify the elements. So we're going to write the name of the non-metal that appear first, and then we don't use mono for the first element. How are you going to remember that? So just bring it to your head most simple elements that we talk about every single day. CO2 and CO. This is carbon monoxide, right? And this is carbon dioxide. See that I'm telling you how many oxygen I have. Here I have 1 and here I have 2. But I'm not indicating that I have monocarbon, so we don't use mono for the first non-metal. We just use mono for the second, okay? This is only for the mono. If it was 2 carbons, so it would be dicarbon, but it's not the case, okay? And then you write the name of the second non-metal. Always add prefix indicating how many, drop end and replace with IDE like we do and ionic, okay? So if prefix calls double O or AO, drop the vowel from prefix. And hydrogen on the left, if it's a gas, we're gonna use ionic compound rule, okay? So here it's pretty simple. So I have 4 phosphorus and 3 sulfur over here, so it will be tetraphosphorus trisulfide. See, regular name of the element, I only add tetra because it's 4, and tri because it's 3, right? Sulfide. So see that I add IDE at the end. Look at the other one. So if it's a gas, will be hydrogen chloride. Okay? So again, that is hydrogen chloride, not hydrochloric acid. And let's try one more. Let's put the formula over here. Draw the formula. So penta sulfur X oxide. So I have 5 sulfur and I have 6 oxygen. So how am I going to write down? S5O6. Same thing here. So I have 4 nitrogen and I have 3 seleniums. So it's going to be Na4Se3. Hydrogen sulfide gas. So I have hydrogen sulfide. So cross the charges and you have H2S. Good? Okay. So this will be for you to practice. So stop your video and check your answers. I'm going to give you an example. I have molecular formula, CO. Number of atoms of first element, I have 1. Number of atoms in the second element, I have 1. So the name will be carbon monoxide. And you're going to do this for all the elements over here. So, and also we have acids. How are we going to name acids? We have oxyacids, the compounds that we have hydrogen and also oxygen, and we have regular acids or hydroacids that only have a hydrogen and a non-metal, like hydrochloric acid. Okay, so let's start with the hydro acids, like binary acids. Acid molecular compound that dissolves in water to produce hydrogen ion. So if you have hydrochloric acid, see that I see aqueous over here? Oh, so when you see this aqueous, we have an acid, and the hydrogen in the beginning and the non-metal. So at the end, you're gonna use ic. For example, hydrochloric acid. Okay, let's write down here. Hydrochloric acid. How you use this? Hydrobromic acid. Oh, you need to write down the acid? Yes. Okay? And you use hydro. Let's test your knowledge over here. So we have HF over there. What is that? Hydrofluoric acid. What is the second one? Hydrochloric acid. Third one, hydrosulfuric acid, hydrobromic acid, and hydroiodic acid. So we have a ternary oxyacid. Oxyacid, we have oxygen on it, like we have over here. So oxygen, and we have hydrogen as well. So here we have a nitrate ion. And look how in the name, nitric acid. So you don't use hydro over here, okay? Hydro, no. So here, when you have polyatomic ion and the ITE, the suffix is changed for alls. If it is ATE, with the suffix is changed for ic. Like here, we have nitrite, so this is nitrous acid. That's pretty. When you have a polyatomic ions, we're gonna use the name of the polyatomic ions. Look at this. Hypochlorous acid. Chlorous acid. Remember, ic, ATE. Look, let's get back over here. ATE is ic, right? ITE is O's. Okay? So look at those ClO3. What do you have over there? ATE. So we'll finish in ic. Cl4 is perchlorate. ATE again. So it'll be perchloric acid. What is ClO? Hypochlorite. See, I put it over here a piece of the table so you can see the polyatomic ions. So we have sodium hypochlorite. That is compound because this is not oxyacid. See the difference? This is oxyacids, we change. And this is metals, that is ionic compound. So see, we have ITE, ATE, ITE is the same name that you have in the polyatomic ions. And here we have the oxyacids. So you change the ITE by O's and you change ATE by ic. Okay? So the name, it's not hard, name oxyacid. So ATE will change end into ic, while ITE will change O's. So we're gonna start again over here. What is the name for the first one? That is, what is CO3? It's carbonate. So it will be carbonic acid. Okay? So here we have CO2, carbonous acid. So we have here ClO4. What is ClO4? That is perchlorate. So it will be perchloric acid. Good. There's chloric acid, chlorous acid, perphosphoric acid, phosphoric acid, phosphorus acid, and hypophosphorous acid. So the only thing that you need to memorize is in the finish with ATE, we change for ic. Finish with ITE, we change for os. And then we have the chemical formulas for acid. So I give you the names and you give me the formula. So let's go with this. The same way that we write down the formula for ionic, we're going to do this over here. Carbonic acid. How are we going to write down this? So we have carbonate. Carbonate, the charge is -2 and the hydrogen is +1. So when you cross, you have this carbonic acid. Okay? Hydrosulfuric acid. Hydrosulfuric acid is, so we have the sulfur, which is -2, and we have a +1. So when you cross, you have H2S. Good? And one of important things in chemistry is the hydrates. Hydrates compounds that contains water molecules weakly bound in the crystals. So hydrates are named from anhydrous or dry compound followed by the word hydrate, with a prefix to indicate the number of water molecules per formula unit of the compound. So here you can see a compound with the water and the other one without water. That's a copper sulfate pentahydrated. So the blue color that you see actually is the reflection of the water that we have inside. Then we dry, so we have white. So here I have 5 water molecules. So that is copper 2 sulfate pentahydrate. So magnesium phosphate X hydrate. So I need to write down the form of magnesium hydrate, phosphate. So I know the phosphate, the charge is -3, and magnesium is group 2, so it's +2. When you cross, we need to remember that you're going to use parentheses. I know that you will not forget, but I keep repeating for you, right? So the 3 come here and 2 come over here. So magnesium phosphate X 6 water, so dot 6 water. Okay? So at the end of this chapter, you're going to find the study guide for the chapter 2, and that's it. That's all. Bye for now.